Alright, this is part one of a review of everything you ever wanted to know about exponential functions. We're going to simplify them, graph them, solve equations, all that kind of good stuff. Problem number one, we're going to simplify this thing. Notice that the roots are the same, so when it comes down to it, we can multiply the stuff that's on the inside here. Now this 2 is in the front, so it's going to stay in the front. So let's put that out there. But now we have the fifth root of stuff. Alright, and what do I have? I have 32 times 6. Alright, that's 192. Okay, and let's see, let's look at the s's. I have s to the 8th power times s to the 7th power, so that is s to the 15th power. T to the 6th power times t is t to the 7th power. Alright, so this is what we get when we multiply these two together. Now we need to simplify this. And I like to color coordinate it. Alright, that 2 is just going to stay there for now. Okay. First of all, looking at the 192, I need to split this apart as something I can take the fifth root of and whatever's left over. Now, from memory, I remember that 32 is actually a perfect fifth power. Now, if you don't have that memorized, then what you're doing is you're looking at the fifth power column, and you see that 32. Alright, the fifth root of 32 is 2. So we like the 32. We're going to use that. Okay, so back to this. That means would be well to split this back up, really back to where it came from, but this time in color. So 192, it came from doing 32 times 6. So I'm really going to go back to that. So I'm going to go back to 32 times 6. I'll put 32 in pink because I can do the fifth root of 32. This can simplify. The 6, there's nothing I can do with that, so I'm going to leave that in blue. So 32 times 6. Now let's do the same thing with the variables. Alright, we'll write the variables as things that can be simplified in pink and things that can't be simplified in blue. Now when we do variables, what we wind up doing to simplify is we divide by the root. 15 is divisible by 5, so I like s to the 15th power, so I'm going to keep it. But I'll just put it in pink. Alright, so there I go. This can be simplified. Now, 7 is not divisible by 5. So what I'm going to do is I'm going to break this up. The closest number that is divisible by 5, less than 7, is 5. So I'm going to split up this t to the 7th power as t to the 5th power with 2 t's left over. Okay, so t to the 5th power times t squared. Now everything you see here in pink can be simplified and brought outside of the radical, out front. So let's do that. So that 32. The fifth root of 32 is 2. Again, we're getting that off the table. Fifth root of 32 is 2. Okay, now the fifth root of s to the 15th power is going to be s to the 3rd power, because we divide 15 divided by 5. The fifth root of t to the 5th power is just going to be t, because 5 divided by 5 is 1, and we don't put the 1. So here are the three things in pink, and now they will be out in front of the radical. Alright, now the things in blue are going to be stuck under the radical. So I've got my fifth root of 6t squared. Now don't forget about this 2 that's been there the entire time. 2, 2, 2. It's still there. So we needed to go ahead and do one extra step. Okay, so this is going to be 2 times 2, of course, is 4. So we will have 4, and then the rest of it, s to the 3rd power t and then the fifth root of 6t squared. So this will be the final answer for number 1. Look at problem number 2. 16,807. Is that a perfect fifth power? There it is. Yes. The fifth root of that number is 7. Okay, so that makes this 7 to the negative 2 power. And of course that negative 2 power drops you down, so this will be 1 over 7 squared, which is going to be 1 over 49. So that is the answer to number 2. Be very careful with number 3. Is this negative sign included in the fourth root, or is it outside of the root? It's outside. Remember, unless there are parentheses, okay, this power only pertains to the number. This power, including the fourth root, does not affect the negative sign. The negative sign will stay out front the entire time. So I'm going to take this, and remember, this 5 over 4 is power over root. So what I'm looking at here is this is the fourth root of 625, and then that is going to be raised to the fifth power. The negative stays out front. Now, the fourth root of 625, okay, is 5. So that gives us negative, and so I have 5, and then so that'll be 5 to the fifth power. So 5 to the fifth power is 3,125. So this is going to be negative 3,125. So that is the answer to number 3. Okay, this time the negative is in parentheses, so watch out for that. When you have a negative power, that drops you down to the other side of this invisible fraction. So that's going to give us 1 over negative 3 to the fourth power. Now, when you raise a number to an even power, when you raise a negative number to an even power, it turns positive. So there won't be any negative sign. So it's just a matter of what's 3 to the fourth power. Now I happen to remember that that is 81. Okay, but here it is. 3 to the fourth power is 81. So that's why this is going to just be 1 over 81. Number 5. Alright, we have a lot of fifth root happening. Let's see, 243. Is that a perfect fifth power? Yes, it is. Alright, the fifth root of 243 is 3. Good to know. And in fact, all of these are perfect fifth power, alright, because for variables you just divide. So, wait, I already forgot what that was. Yeah, the fifth root of 243 is 3. So, this is going to become 3, and then this will be a to the second power. I'm dividing. And then this is going to become b to the fifth power. Alright, so these three things reduce down to this. Now, we still have the negative 6ab that needs to be multiplied. Now, the negative 6 and the 3, those will multiply and make negative 18. A times a squared is a to the third power. B times b to the fifth power is b to the sixth power. Number 6. Alright, we have these negative numbers raised to these powers. First of all, I would deal with this negative exponent, because you know that anything with a negative exponent is going to drop down to the other side of the invisible fraction. So that means what I really have is negative 2 to the fifth power, okay, is not moving, and I have negative 2 to the 7th power, but this is going to be over negative 2 to the 3rd power. Now, when you have a negative number raised to a power, sometimes the negative stays, and sometimes the negative goes away. If you have an odd number, an odd power like 5, the negative stays. So this is going to be the same thing as negative 2 to the 5th power. If this was even, like negative 2 to the 4th power, then that would just equal 2 to the 4th power. So if I have an odd exponent, the negative stays. If I have an even power, the negative disappears. So keep that in mind. As you notice that all of these exponents are odd. So all 3 of the negative signs are going to stay around. So it's sort of like you have this. You have negative 2 to the 5th power times negative 2 to the 7th power over negative 2 to the 3rd power. Okay, all the negative signs survive. Now 2 to the 5th power is 32. So I have negative 32. 2 to the 7th power, I don't know what 2 to the 7th power is. 2 to the 6th power, oh, you know what, maybe I should leave it. Yeah, you know what, I'm sorry, let me backtrack a little bit. Let me not, all of these are like bases. Let's simplify it all. Alright, that was silly of me. These are like bases. So negative 2 to the 5th power times negative 2 to the 7th power. I can combine those, and that'll be negative 2 to the 12th power. Alright, I'm adding 5 and 7. Okay, now in the denominator I have negative 2 to the 3rd power. So 3 of these negative 2's are going to cancel out 3 of these negative 2's. So that's going to leave me with 9 negative 2's. So this is going to be negative 2 to the 9th power. So it's just a matter of, will the negative stay or go as I get rid of the parentheses. And because it's odd, the negative is going to stay. So the final answer is going to be negative 2 to the 9th power. Just got to take the parentheses away, and the negative stays. And yeah, anything that's a 4th power or higher, you can just leave it. Well, strike that. What I mean to say is anything that's not on the table that you're given, you can just leave it. So 9th power is not on the table, so let's just leave it as negative 2 to the 9th power. Okay, so that is the answer to whatever problem I just did. Number 6. Alright, number 7. What is going on here? This negative power, once again, means you drop it like it's hot. I feel like I need to change colors. I'll just change to green. So if I do this, I drop it down. So that's going to leave me with 1 over negative 512 to the 5 over 3 power. I need more space. Okay, I dropped it down. Now, 5 is the power, 3 is the root. So I'm going to do the cube root and the 5th power. So if I do that, here I go. Here's the cube root of negative 512. And then here's the 5th power. And all of that is in the denominator. So you can take the cube root of a negative number. It'll just be negative. The cube root of negative 512 is going to be negative 8. So I've got negative 8. And then I've got negative 8 to the 5th power. So it's odd, so the negative is just going to stick around. So I know the answer is simply going to be a negative number. So it's just really a matter of what's 8 to the 5th power. Alright, so 8 to the 5th power is 32,768. And the negative stays around through that entire process. Number 8, time to simplify this thing. 56 is not a perfect cube. Okay, I have 8 and 27. Do either one of those divide evenly into 56? Yeah, 8 goes into 56, right? 56 divided by 8 is 7, obviously, alright, if you know your multiplication facts. So what you want to do is, let's go ahead and split this thing up. Everything that is a perfect cube we'll put in pink. So 56 is 8 times 7, so there's my 8, and then times 7. X to the 5th power. The best thing I can do with that, as far as wanting to divide by 3, is I can write it as x to the 3rd power with just a couple of x's left over, x squared. And there's nothing I can do with y, so I'm just going to put y. So these two pink things can be simplified and brought out, because the cube root of 8 is 2, and the cube root of x to the 3rd power is x. So these two things came out. The blue simply stays under the radical. And that would be your answer to number 8. Number 9. Alright, let us consider the basics. Okay, if I had n to the 3rd power times n to the 4th power, what would this be? This would be n to the 7th power. So when you're multiplying like bases, you add the exponents. You don't multiply. It wouldn't be n to the 12th power. Okay, you add. So look, when you have fractions, it's still going to work the same way. Alright, we're just going to add the exponents. So we have this, but we're doing 1/2 plus 2/3. So we just need like denominators and such. So I'm going to do this off to the side. Okay, 1/2 plus 2/3. Let's change these both into a denominator of 6. So I could do this times 3 and do this times 2. So that's going to give us 3 over 6 plus 4 over 6, which is 7/6. So this is going to be a to the 7/6 power. Okay, and let's just leave it like that. Okay, when you have a power like this on multiple things, you have to do the power to each one of these factors. So basically, you see the -2, right? So I'm going to do -2 to the 5th power, including the negative sign, alright? But I'm also going to do x to the 2/5 power to the 5th power, and I'm also going to do y to the 1/5 power to the 5th power. Now, -2 to the 5th power, an odd power, the negative just sticks around. So it's going to be negative something. 2 to the 5th power, I believe, is 32. Okay, take a quick peek. 2 to the 5th power, yes, is 32. Okay, now, when you raise a power to a power, you multiply, right? So I'm going to multiply these, but basically these 5's are going to cancel out. And that's just going to leave me with x squared. Same thing is going to happen here. If I multiply these, what's really going to happen is these 5's are going to cancel out. So that's just going to leave y. So that's it. That's the answer for number 10. It's negative 32x squared y. We're always looking for something to be the same. And what we've learned is, let's look back. Like, take a look at these. When the roots were the same, we were allowed to go ahead and multiply the stuff inside. Now it's going to be very similar here. See how the powers are the same, the 1/4 power? If the powers are the same, you can go ahead and do the division that's implied by this fraction bar. Just keep your same 1/4 power. So what's 55 divided by 5? That's right, that's 11. So it'll just be 11 to the 1/4 power, then cubed. How do you raise a power to a power? You multiply. So this will just be 11 to the 3/4 power. And that's the best we can do for number 11. Alright, number 12 will be the last problem on this video. That'll be the end of part 1. And we will do the next part. There's 3 more parts coming, so stay tuned for those. But this will be the last problem on this video. What to do? Well, when I have a negative power on a fraction, I find that the most convenient thing to do is the reciprocal. So this would be the same thing as having x over negative 2. See, I just did the reciprocal. And putting now a positive 4 power. Okay, this positive 4th power is going to make the negative sign go away. But what I'm dealing with is x to the 4th power over 2 to the 4th power. Right? The negative sign is gone because of it's an even power. 2 to the 4th power, I believe, is 16. So x to the 4th power over 16. So you have to do that because it's on the chart, so you got to do it. Alright, 2 to the 4th power is 16. Okay, so this is the final answer. Alright, that concludes part 1 of our review of exponential functions. Just a sneak peek ahead, it looks like in part 2 we're going to start off graphing some exponential functions.